Morning students. Today we are going to learn about JK flip-flop, D flip-flop and T flip-flop. Okay. The circuit diagram for JK flip-flop. This is the symbol for JK flip-flop. This is the truth table for JK flip-flop. Okay. JK flip-flop has two inputs J and K and two outputs Q and Q bar. Okay. To activate flip-flop, you have to use clock pulse. Okay. So in JK flip-flop, we have two inputs and two outputs. Okay. Q is the output of JK flip-flop. Q bar is the complement of Q. Okay. J can be either 0 or 1 and K is and the value of K can be either 0 or 1. So there are four possible combinations 0 0 0 1 1 0 and 1 1. Okay. First I am applying J is equal to 0, K is equal to 0. Okay. In AND gate, if any one of the input is 0, then the output will be 1. If both inputs are 1, then the output will be 0. Okay. Just opposite to the AND gate. Okay. Now J is equal to 0, K is equal to 0. Now I am applying clock pulse. Here in this Q bar is connected to first input of this NAND gate. Q is connected to third input of this NAND gate. Okay. First you take this NAND gate. Here we have J is equal to 0. Clock is applied. So clock is equal to 1 or clock is high. In the first input we have Q bar. Okay. We don't know the value of Q and Q bar. Now we assume that Q is equal to 0. Previously 0 in the output Q. Q is 0, then Q bar is equal to 1. This 0 is applied to this input. Okay. If any one of the input is 0, then the output will be 1. Similarly, the output of this NAND gate is also 1. Here also the output will be 1. Okay. Q is 0. So here we have 0. If any one of the input is 0, then the output will be 1. This one is applied to this NAND gate. Now both are 1. So you will get the 0 output. Okay. So if J is equal to 0, K is equal to 0, there is no change in the output. Previously 0 in the output. Now also after applying clock pulse also we will get 0. Okay. So J is equal to 0, K is equal to 0, then there is no change in the output. Next I am applying J is equal to 0, K is equal to 1. Okay. K is equal to 1. Now I am applying clock pulse. Okay. In this NAND gate, one of the input is 0. So if any one of the input is 0, then the output will be 1. So the output of first NAND gate will be 1. Okay. Here in the first input we are applying clock. In the second input we have 1, but here Q is connected. Okay. We don't know the value of Q. Now we assume that Q is equal to 0. This 0 is applied to third input of this NAND gate. Now the output of this NAND gate becomes 1. Since the third input is 0. So here 1. Okay. Q is 0. So if any one of the input is 0, then Q bar is equal to 1. This 1 is applied to here. Now both inputs are 1. So Q is equal to 0. So previously 0 in the input, now also 0 in the output after applying clock pulse. Next I am assuming Q is equal to 1. I am applying same J is input. J is equal to 0, K is equal to 1, and then applying clock pulse. Here you assume that Q is equal to 1. Now this 1 is applied to third input of this NAND gate. Now you can get 0. The output of this NAND gate is 0. Okay. If any one of the input is 0, then the output will be 1, 1. This 1 is applied to here. Already here we have 0. So if any one of the input is 0, then the output is 1. And here we have 1. Here also 1. Both inputs are 1. Then the output becomes 0. Okay. So now Q is equal to second case. We are applying J is equal to 0, K is equal to 1. Then we are applying clock. Okay. If any one of the input is 0, then the output is 1. Here in the first input we are applying clock. In the second input K is equal to 1. Here Q is connected. Okay. We don't know the value of Q and Q bar. So I am assuming Q is equal to 1. If you apply 1 here, you will get 0. Now, if any one of the input is 0, then the output will be 1. This 1 is applied to second input of this NAND gate. Already we have 1 at the first input. So, now both inputs are 1. So, you will get 0. Okay. So, whatever be the value of Q, when you apply J is equal to 0, K is equal to 1, you will get 0. Okay. But in the previous case, when you apply J is equal to 0, K is equal to 0, there is no change. Okay. But now you will get 0. Okay. When you apply J is equal to 0 and K is equal to 1, you will get 0 at the output. Okay. Next I am applying J is equal to 1, K is equal to 0. J is equal to 1. K is equal to 0. Okay. Now I am applying clock pulse. If any one of the input is 0, then the output will be 1. So the output of this NAND gate is 1. Okay. Here in this NAND gate, J is equal to 1. We have applied clock. So third input is also 1. But we don't know the value of first input. Q bar is connected to the first input. Okay. Now I am assuming that Q is equal to 0. Q can be either 0 or 1. First I am assuming that Q is equal to 0. Okay. Now I am taking Q is equal to 0. Okay. Now this 0 is applied to this input. Okay. This 0 is also applied to this NAND gate. So if any one of the input is 0, then the output will be 1. So Q bar is equal to 1. So Q bar is 1. This one is applied to here. So here also we have 1. This 1 is applied to here. So J is equal to 1, clock is also high, the first input is also 1, so here we have 0. Now I am getting 0 here. If any one of the input is 0, then the output will be 1. So now Q becomes 1. Okay. Previously 0 in the output. After applying clock pulse, you will get 1. Okay. So when J is equal to 1, K is equal to 0, you will get the output 1. Whatever may be the value of Q. Q can be either 0 or 1. Okay. Now I am applying the same input. J is equal to 1, K is equal to 0. Now I am taking Q is equal to 1. Okay, I am assuming that Q is equal to 1. Here one of the input is 0, so the output of NAND gate will be 1. Q 1 means Q bar is 0. The 0 is applied to here. So first input we have 0. Okay. So one of the input is 0. So the output will be here Q1. So Q bar is 0. So here we are applying 0. One of the input is 0. So the output of NAND gate will be 1. Okay. So now we are getting the 1. Okay. So when J is equal to 1, K is equal to 0, whatever may be the value of Q, you will get 1. Okay. Next, in the fourth case, J is equal to 1, K is equal to 1. So now I am applying J is equal to 1, K is equal to 1. This NAND gate, second input J is 1, clock is high, but we don't know the value of Q bar. Here also the first input clock is high, second input is 1, but we don't know the value of Q. So now I am taking Q is equal to 0. Q can be either 0 or 1. First I am taking Q is equal to 0. Just I am assuming that Q is equal to 0. Okay. Now the 0 is applied to this NAND gate. Okay. Now one of the input of this NAND gate is 0. So the output will be 1. Okay. Next, q is equal to 0 means q bar is 1. So now this one is applied to this NAND gate. So here all are high, so the output will be 0. Now one of the input is 0, so the output becomes 1. Okay. Zero will be changed to 1. Okay. Next I am assuming q is equal to 1. I am applying j is equal to 1, k is equal to 1. Now we have 1 at the output. I am assuming that q is equal to 1. Okay. I am writing here. Okay. Q is 1. This 1 is applied to here, so all are 1. So here you can get 0. Now one of the input is 0, so you will get 1. Q bar is 1. Okay. Q bar is connected to here. Already j is equal to 1, clock is high, so all are 1. So the output of first NAND gate is 0. Now one of the input is 0, so the output becomes 1. Q bar 1, j is equal to 1, 0. Sorry, once again I am explaining. I am taking q is equal to 1. Okay. Q is equal to 1. If q is 1, then q bar is equal to 0. Here q bar is applied to here, so one of the input is 0, so you will get 1. Q is applied to this NAND gate. Now I am taking Q is equal to 1. So all are 1. So all the inputs are 1. So you will get 0 here. If any one of the input is 0, then the output becomes 1. Now Q bar becomes 1 after applying the clock pulse. Okay, this one is given to this input. Now both are 1, so the output Q becomes 0. Okay, please note it here. If J is equal to 1, K is equal to 1, if 0 is there in the Q, after applying clock pulse, you will get 1. 0 is changed to 1 after applying clock pulse. Similarly, previously 1 in the output, after applying clock pulse, you will get 0. Okay, so 1 is changed to 0. Okay, 0 is changed to 1, 1 is changed to 0. Okay, this action is called toggling. Okay, 0 to 1, 1 to 0 changes is called toggling state. Okay, so if J is equal to 1 and K is equal to 1, the output will be the complement of Q. Okay, this state is called toggle state. Okay, when you apply J is equal to 0, K is equal to 0, there is no change. When you apply 0, J is equal to 0 and K is equal to 1, you will get 0 output. When you apply J is equal to 1, K is equal to 0, you will get 1. When you apply J is equal to 1 and K is equal to 1, you will get the complement of Q. Okay, that state is called toggle state. Okay, this is the working of JK flip-flop. Next we will see about D flip-flop. Okay, this is same as RS flip-flop or JK flip-flop. Sorry, this is SR RS flip-flop. Okay, here by making S is equal to R bar, you will get D flip-flop. The circuit becomes D flip-flop. Okay, this is the circuit for D flip-flop. This is the symbol, this is the truth table. Okay, in D flip-flop we have single input and two outputs Q and Q bar. Okay, to activate flip-flop we are applying clock pulse. Okay, here we made S is equal to R bar. That means if S is equal to 0, R is equal to 1. Okay, first I am applying D is equal to 0. D is equal to 0 means S is equal to 0, R becomes 1. All of you know that if S is equal to 0, R is equal to 1, then the output will be 0. Okay, to clear the RS flip-flop, you have to set the reset is equal to 1. Now reset is 1, so Q is equal to 0. So if you apply D is equal to 0, you will get the 0 at the output. Okay, next I am applying D is equal to 1. Now S is equal to 1, R is equal to 0. When you set S is equal to 1, you will get Q is equal to 1. That's it. So D is equal to 1, S is equal to 1. Here the output of NOT gate is given to R, so R is 0. S is equal to 1, R is equal to 0, you will get Q is equal to 1. So if D is equal to 1, Q is equal to 1. You see the table here. If D is equal to 0, the output will be 0. If D is equal to 1, then the output will be 1. Okay. Are you able to follow? So here we have single input. D can be either 0 or 1. Now I am applying D is equal to 0. D is equal to 0 means S is equal to 0, R is equal to 1. If R is equal to 1, then the output will be 0 in SR flip-flop. SR or RS flip-flop. If reset is equal to 1, then the output will be cleared. So D is equal to 0, you will get 0. Okay. If D is equal to 1, S is equal to 1, R becomes 0. Okay. When S is equal to 1, R is equal to 0, the output will be 1. To set the output 1, you have to set the input S is equal to 1. Okay, now D is equal to 1, so S is equal to 1, so Q is equal to 1. Okay, so if D is equal to 0, then the output will be 0. If D is equal to 1, then the output will be 1. Okay, this is the working of D flip-flop. Next, this is the circuit diagram for T flip-flop. D flip-flop is also called delay flip-flop because we are giving the 0 input, you will get the same output. Similarly, when you apply 1 at the input, you will get the same 1 at the output. Okay, so just for giving delay, we are using this D flip-flop. So D flip-flop is also known as delay flip-flop. Okay, T flip-flop or toggle flip-flop. Okay, here by connecting J is equal to K, by joining the inputs J and K, you can convert JK flip-flop into T flip-flop. Okay, so this is the J input, this is the K input joined together and taking a single input. This input is called T. Okay, in T flip-flop we have single input and two output states, Q and Q bar. Q is the output of T flip-flop. Okay, now you are applying clock pulse. T is a single input, so it can be either 0 or 1. Now I am applying 0. 0 means J is equal to 0, K is equal to 0. In JK flip-flop, if J is equal to 0, K is equal to 0, then there is no change in the output. Okay, previous value of Q. Okay, if T is equal to 1, J is equal to 1, K is equal to 1. In JK flip-flop, if J is equal to 1 and K is equal to 1, then you will get the toggled output. That means Q bar. So when T is equal to 0, the output, there is no change in the output. If T is equal to 1, then you will get the toggled output. That means Q bar. Okay, so T is equal to 0, Q. If T is equal to 1, then the output will be Q bar. Okay, so this is the working of T flip-flop. Okay, thank you.